All right, class. So here's an example of linear regression and how to use your calculator to get most of your answers. So this is just a basic example I found regarding wait times and the number of lanes open at a particular Walmart. So to start, it says the busiest season for Walmart is the Christmas holiday, and weekends see a tremendous number of customers. Last year, Walmart conducted a study as to the amount of waiting and time in checkout lines as customers had to wait. On Saturdays and Sundays of its holiday season, it opened a different number of checkout lanes for customers between 1 p.m. and 4 p.m., its busiest times. The measurement was the average wait time for a customer to go through the lane and complete the transaction. A different number of lanes was open each day. So the data is given below. So here's all of our data. They give us the weather, the number of lanes open, and the approximate wait time per customer. So the first question says, what's the explanatory variable? Well, the explanatory variable you have to remember is what is explaining what's happening. So if we're talking about lanes versus wait time, the number of lanes open explains the wait time. All right, so our explanatory variable is lanes, while our response variable, which is the variable that is responding to the explanatory variable, so it's like our answer, is your average wait time. All right, so for question number 2, it says, for question number 1, make a scatter plot on your calculator and draw it below. So obviously I'm not going to draw it, but I'm going to show you guys how to create it on your calculator. So over here I have a emulator that shows what your TI 84 or 84 plus or 84 plus CE looks like. I'm using the 84 plus CE, but the buttons are pretty much the same whether you're using an 84 or 83. Now again, you have to have a graphing calculator to do this. Only a few scientific out there will do what you want it to do. So the very first thing I'm going to do is I'm going to click this button right here. If you can see my cursor, I'm going to click the button that says stat. Alright, and once I have that button clicked that says stat, I'm going to edit because I need to put in the data. So I've already done it, but pretty much you guys want to go in and do the same exact thing. So under L1, you want to put in all of your lanes. So how many lanes are open? 5, 12, 11, all the way down to 8. And then in L2, you want to go on and put in your average wait time. So again, I just started with 12.2 all the way down to 5.6, and I typed all those in, making sure I was being very accurate with how I'm typing them in so that I don't have any errors in my data entry. So again, if you're going too fast and you mess up how you type the numbers in, that can throw off your entire answer. Alright, so once we have that in there, what we're going to do is we're going to go to second y equals, which is your stat plot. So again, second y equals pulls up your stat plot. And you're going to press enter on number 1. The first thing you want to do is make sure that it's turned on. Alright, because you want it to actually print. The next one is your type. Now all these types we'll get to throughout the course, but for today we're focused on this first one. You can see it looks like a bunch of little dots. That's showing you like a dot plot. So we want to make a dot plot or a scatter plot. So we're going to click enter on type 1, so that very first type. Now your X list should say L1. If it doesn't say L1, what you can do is you can hit second 1 to get L1, and then your Y list should say L2. And again, if it doesn't say that, hit second 2 to make it say L2. Alright, once you have that in there, we're going to go ahead and try to graph it. We might not be able to see it, who knows, but let's try to see what it looks like. So I hit graph, you see it's kind of off center, and the reason why it's kind of looking off is because my calculator is set up for regular plots, like y equals mx plus b type plots. Because we're doing statistical plots, you want to kind of change your focus of your graph. So what we're going to do is hit zoom, and we're going to go down to number 9. So zoom 9 will give you a stat. And here we have our nice little pretty scatter plot. Alright, so again, second y equals gives you the plot, graph it. If it doesn't look right, hit zoom 9 and it will automatically fix it for you. Alright, so to question number 3, it says there's a clear outlier. circle it. Well, our outlier is down here at the bottom, and we're calling that an outlier because it's off of the general form of the graph. You see all the other plots are up here. They're kind of pointed downward in a nice smooth pattern, but this plot down here is off. All right, it's off of the general pattern, so we're going to call that an outlier. Question number 4 says, give a reason for your outlier. Well, first of all, I need to figure out what the outlier is. If I was to wager a bet, because it's so low, it looks like it's our lowest wait time. If I go back up here to the data and look at, what day is this, 12/29, we see that our wait time was 1.1 minutes with 4 lanes open. Well, that's way off of the wait times for any other days, and it's probably because it's snowing. All right, if you look at all the other days, it's either sunny, cloudy, or rainy. We had a good amount of lanes open. This particular day, they only had 4 lanes open with the lowest wait time. So again, it's probably happening because it's sunny. So if I was to give a reason for that, I would say the weather was snowy, therefore there were very few customers. All right, so then the next question says, all right, well, if we have this outlier that really is not really giving us any good information for the particular data that we're looking for, we can go ahead and eliminate that outlier. We don't need it in our data set. So they want us to create a least squared regressions line for the data, but they want us to take out the outlier. So what I'm going to do is I'm going to go back to stat on my calculator, go back to edit, and I'm just going to delete that outlier. So I'm going to delete this 1.1, and I'm going to delete that 4 that correspond to it. All right, and so now I can see all my data again without it. And if I want to, I can go ahead and graph it again, and you see the outlier is gone. All right. So to get your least square regression line, the actual equation, what you're going to do is you're going to hit stat. You're going to go over to calc. Oh, I went too far. And we're going to go to ln reg, which is number 8. We want a plus bx. All right, so I'm going to go down to ln reg. I'm going to press enter. Again, your x list should say L1, L2. All that stuff should already be set up. Now, if your calculator doesn't look like mine and it's not showing any of that stuff, that's okay. Just go to ln reg and press enter, and it will still give you the information. All right, so here we have it. We have our A value, we have our B value, and we're going to basically type it into this form to get our least squares regression line. So I'm going back over here to my Word document, and I'm just going to type that out. Let's see. I'm going to be accurate on how I type it. So we're going to do Y hat, and we use the hat because we're saying it's basically an estimate or approximation or a guess based off of our data. So Y hat equals, we're going to do our A value first, so 14.96. And remember, on Connect Math, you want to make sure that you're doing however many decimal places they ask for. Plus, in this case, a negative. So I'm going to say negative 0.96x. All right, so that would be our least squared regression line. All right, so the next question says, what does the slope mean for your least square regression line? So basically, your slope is saying for every one increase in your x value or your explanatory value, your y value increases by whatever the slope is. So I would say, to make it easy, as the number of lanes increases by 1, spelled it wrong, sorry. The average, that's my y value, wait time decreases by 0.96 seconds, minutes. So every lane that I increase or every additional lane that I open, I'm going to decrease the customer's wait time by almost a minute. All right, so the next one says, what specific point does your least square regression line guarantee to go through? So one of the key things that you want to learn for your regression is that the least squared regression line always goes through uh, the mean of the explanatory values and the mean of the response variable. So basically, it's always, your line will always go through the mean of the two variables. So if I took the data and found the mean for each, that point is what it would go through. So again, to quickly do this on the calculator, I'm simply going to hit stat, go over to calc, and I'm going to do two variable statistics. And again, I want it to be L1, L2. Again, if your calculator doesn't look like mine, that's okay. It will automatically do L1, L2 for you. And I press enter and I see the mean. Remember, X bar is the symbol for your mean. So the mean for the X's, or your explanatory variable, is going to be 8.45. So let's say 8.45, comma, and then our mean of our Y value is 6.82. And that's given right here, 6.82. So our point, let me get it in here first. Our graph, our line, is guaranteed to kind of go through that point. And so if I wanted to, again, be more specific, I can go to y equals, and I can type in my least square regression line. So that 14.96 minus 0.96x. Sorry, it didn't give it to me. 14.96 minus 0.96 x, and I can graph that along with my scatter plot, and I can see that least square regression line going through the data. Now, again, I can scroll through this line if I wanted to, and I'm sure that I would find this point 8.45, 6.82, because again, that point will go through, or that line will go through the point. All right, so the next thing says, describe the form, the direction, and the strength of your graph. So that's a common question that they ask for when they're talking about regression. So you want to give the form, the strength, and the direction. So I would just say, I mean, this is a pretty good line that's going through this data. So I would say it's a fairly strong negative, since it's sloped downwards, linear because it's in the form of a line, correlation. So again, a fairly strong negative linear correlation. The fairly strong is given the strength of it. And I say it's fairly strong because the points are pretty close to the line. It's negative because it's sloped downward from left to right. And it's linear because the points are kind of forming a straight line. It's not a perfect line, but it's kind of in the form of a line. All right, so the next thing you're going to have to do a lot on your homework, which is find your R value. Your R value tells you how well correlated the data is. So the way that you want to find your R value is you hit, again, stat, calc, and we're going to do our linreg again. So number 8. And type all that stuff through. No big deal there. And we're going to press enter. Now, I'm doing it like this because I'm trying to show you guys that many times, because your calculators aren't set up for statistics, it's not going to show you everything you need. So when I click linreg number 8, because I haven't set up my calculator yet, I'm only seeing my A and my B values. I want to be able to see my R and my R squared as well. So if you're like me, you don't see your R and your R squared, you're going to hit second, catalog. All right, so again, second 0, and that's going to pull up the catalog. From there, you want to go to D, which is diagnostics on. So you're going to scroll all the way down till you get to diagnostics on. You're going to press enter, and press enter again. It should say done. All right, once you get that on this first time, you don't ever have to do that again. But you want to have it on again so that when you go to stat, and you go over to your linreg, so stat calc number 8, and you actually calculate it all the way through, now it should pull up your R and your R squared value. All right. And so what is the value of R? According to my calculator is negative 0.88. And what does that mean? Well, it means that there is a strong negative correlation between the variables. All right, so again, negative 0.88 is our R. And that tells me that there's a negative strong. It's negative because the actual sign is negative, and it's fairly strong because it's close to 1, or in this case, close to negative 1. All right, so the next question says, what is our R squared value? Well, R squared in this case is 0.7, let's say 78 to be precise. All right, and so that R squared value is telling you that how much of the variation in Y can be explained by the least squared regression line. So in this case, I can say 78% of the variation in wait times can be explained by the least squared regression line. All right, so again, 78% of the variation in Y can be explained by the least squared regression line. All right, so next question just goes to like, what's the purpose? Why do we even calculate any of this? Well, we're calculating this so that we can we can predict values. So, for instance, in question number 11, it says, well, what would happen if I had 9 lanes open? How long would my customers have to wait? Well, if we go back up here and take our equation, 14.96 minus 0.96x, we can figure out. Now remember, your x is your explanatory, and that was the number of lanes. So if I do 14.96 minus 0.96 times 9, which is the number of lanes we want open, we can figure out our y value, or we can figure out our wait times. So I'm going to go back over here to my calculator screen. Now I'm just going to type that in. And I get 6.32, which in this case, since we're talking about our wait times, we're talking about minutes. So 6.32 minutes. The next question says, if Walmart decides that it wants its customer to wait no longer than 4.5 minutes, how many lanes should it open? So again, this time they're giving us the wait time. They're looking for the lanes, or they're looking for X. So I'm going to set up as 14.96 minus 0.96. Good. Just checking my equation. X equals this time 4.5. Alright, so to solve this out, I'm going to subtract. So I'm going to do 4.5 minus the 14.96. And then I'm going to take that answer and I'm going to divide it by the negative 0.96. So I'm just solving for X. And I get that X equals 10.8, let's say 10.9. So the answer, obviously I can't open up, oh, I typed in 12, sorry. Obviously I can't open up 0.9 of a register, so to properly answer the question, I'm going to go ahead and round it. So I'm going to say 11 lanes. Alright, I hope this helps you out. If you have any questions about how to use the calculator, or what buttons to push, or if you're pushing buttons and you're not getting what I'm getting, go ahead and shoot me an email, and so I can help you out with that.